In this lecture, we'll talk about an application of exponents scientific notation. Scientific notation is used in a science to represent the number in an exponent if the numbers are extremely large and if the numbers are extremely small. We will learn expressing the numbers in scientific notation. We will convert the numbers in scientific notation to standard notation. We will use the scientific notation in calculations. A scientific notation in a standard form can be written as a times 10 to the power n, where absolute value of a must be greater or equal to 1, n is less than 10. N is an integer, which can be a positive number, a negative number, or a zero. A can be positive or negative. That's why when we compare, we write a in an absolute value, that telling us that a has to be greater than equal to 1 and less than 10. In scientific notation, a multiplication cross is commonly used. Determine the sign of n. If we're moving the decimal point, which makes the number smaller, n will be positive. If we're moving the decimal point that makes the number bigger, then our n will be negative. If the decimal point is not moved, our n will be 0. Let's look at this with the example in the form of a table. Scientific notation 8 times 10 to the power n, there is a 1 non-zero digit to the left of the decimal point. Let's understand this table. Let me get the pen here. Here, my number is 420. I want my a, which is 1 or greater but less than 10. You can put the decimal here, which is saying you have $420. Now, if you're trying to make the number between 1 and 10, you know you have to put the decimal somewhere here, right? So that's how we get this 4.2. Now, original number was 420. We made the number smaller, 4.2. And therefore, you have 2 digits between the two decimal. And therefore, you have a power positive 2. Let's try the second example. This time, I have 42. 42 is still more than 10, meaning I'm trying to make a number smaller. The decimal is right here, $42. To make the number between 1 and 10, I must put the decimal right there. So I made the number smaller again, and I only moved one place. And therefore, I have 10 to the power positive 1. The next example, 4.2, is already in the form I want my a to be. I am not going to move my decimal anywhere, and therefore you see the 10 to the power 0. So when you don't move the decimal anywhere, your exponent will be 0. The next is 0.42. Now, the a has to be 1 or more. This is less than 1, so we need to move the decimal right there. We made the number bigger than the original number by moving one place, and therefore my power here becomes negative 1. Let's look at the next example, 0.042. So I'm going to make that as 4.2 right there. The number became bigger than what it is by moving 2 places, and therefore my exponent is negative again. All these numbers that you see right there are your scientific notation. Let's write the numbers in scientific notation now. Here I have 5,876,000,000. That's quite a big number. Let's first put the decimals. So I have 1 decimal, and you can put the 0 right there. Now, to get my a, I have to put the decimal right here. So my A will be 5.876. That is number between the 1 and 10. Now, because the number I have, I made it smaller than the original number, my exponent will be positive. Let's count how many digits we have between the two decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore, my scientific notation will be 5.876 times 10 to the power 9. Let's try another example. I have 0.000075. This number, I'm trying to first get my A. So to get my A, the number between 1 and 10, my decimal will go right above here, between 7 and 5. So my A is 7.5, which is a bigger number than the original number. And therefore, when I write my 10 to the power, my N will be negative. I will count now how many places I have between the two decimal. 1, 2, 3, 4, and 5. So that will give me my scientific notation 7.5 times 10 to the power negative 5. This number is extremely small number. It's 75 millionth of a number, which is quite small. Here is another number 2. 2 is already the number I want between 1 and 10. So basically, I will not change it. 2 I can write simply as a 2 times 1. Now 1, with the rule of the exponents, I can write again as 10 to the power 0. So 2 can be written in a scientific notation as 2 times 10 to the power 0. I did not move any decimal to the right or the left, and therefore the power remained 0. Now let's write the number in standard form. Here is the number 8.7 times 10 to the power 6. Because the power here is positive, we're going to make the number bigger than what it is, basically adding the 0 on the right side of the number. So by moving the one decimal place right here, let me get the pen here. Moving the one decimal here, the number becomes 87. We have to add now 5 more 0 because we are moving 6 times. I already moved 1 time, so I'm going to add 5 more zeros. This will give me 8,700,000 as a number. So if you see that total zeros I added are 5 because I already moved 1 time. And therefore, I needed to add 5 more 0 to get the original number as 8,700,000. Here is another example. 3.4 times 10 to the power negative 3. First, let's move the number to the left. So I already moved 1 time by moving to the left. We have to go 3 more times. Therefore, I must add 2 more zeros in the front. Whenever you have a negative exponent, the number will tend to get smaller than what it is. So here I add 2 more zeros. So from here, I could have done the same thing. 1 and for 2 and for 3. And there goes my decimal. So that's how you get 0.0034. Which is a small number. 8.67 times 10 to the power 0. 10 to the power 0 meaning you're not moving decimal to the right or left. It's going to stay the way it is. 8.67 times 1. 10 to the power 0 is 1, which is 8.67. So 8.67 is your standard number. 8.67 times 10 to the power 0 is your scientific notation. Let's do some calculation now. We will write the number in scientific notation also in the standard notation after we perform the operation. Here we are multiplying 5 times 10 to the power 4 and 3 times 10 to the power 2. Let's rewrite this problem. And we are removing the parenthesis, and as you can see, I have two numbers and I have two exponents. I will multiply 5 times 3 is 15, and then I'm going to use a product rule that will give me 10 to the power 6. 10 to the power 4 and 10 to the power 2, I will add the power 4 plus 2 to get 6. This is our original number. I'm going to change this to scientific notation. 15 I can write as 1.5 times 10. Now 15 I can write as 1.5 times 10. And therefore, I will use here a product rule one more time. And that should give me 1.5 times 10 to the power 7. And that is our scientific notation. Let's try one more example. Here we are dividing 8 times 10 to the power 3 divided by 2 times 10 to the power 2. Let's kind of separate them, and we will reduce 8 and 2 to get the 4. And here I'm going to use a quotient rule, meaning when we divide with the same base, I'm going to subtract the power. That will give me 4 times 10 to the power 1. 4 times 10 to the power 1 is my scientific notation. 10 to the power 1 is 10, and therefore 4 times 10 equals 40 is my standard notation. If needed, you can watch the video again.